You should be live. Hello, everybody. Good evening. Just decided to quickly jump on and do a quick new stream and continue where we left off. So yeah, we'll just jump into it. So last stream, I was working on, where are we? Let's forget where it is. Here we go, physics project. We were working on getting the linear and angular velocity of our hands to match up the movement. And we got pretty close where we need to be with, if we're not holding anything, but if we are holding something, things fall apart. Now, since my last stream, I have been improving a few things and working on a few things, but I still haven't found an answer to that problem yet. So I'm actually going to leave that alone for now. I think the answer actually lies in the fact that the force and torque are applied to the hand. That's handled in physics. And then the impact on the thing that you're holding is handled in the physics process of the thing that we're holding. And my suspicion is that there is a lack of transfer of power there, that it's more the physics engine is more going back to what the actual movement ended up being and sort of translating that to whatever attached object there is. There's might be that there's some shortcuts there or something else. I'm not quite sure. One thing that I did realize working on the angular velocity is I went back to using Quaternions to do all the calculations, which makes it doesn't actually make sense in the end. But generally speaking, because a quaternion is an axis with a rotation around that axis, there's a whole bunch of math that becomes a lot easier when you do things, especially when you look at Euler angles where you have, rotation X, rotation Y, rotation Z. As you perform that rotation frame by frame, it's not just a, doubling of the amounts. Every bit of rotation sort of influences the other angles. And that's something that quaternions don't have. So I ultimately went down the route of using quaternions here. But the problem with quaternions is it is an orientation format. So it's an axis with a rotation around that axis expressed as a cosine of that rotation. That means that you can never rotate more than 180 degrees. Well, 360, because the moment that you go over 180, then the axis gets inverted, and then you get the other 180 degrees rotation. Now, at the moment that you obviously get faster movement, where we rotate more than 360 degrees in 1 second, we get weirdness. So, and that's probably why the hand, eventually when we increased the mass, the hand started doing really weird things. So I actually went back to just using all the calculations from the Euler angles, which in this case is actually justifiable because we are ending up applying those rotations every physics frame. So they're kind of small enough that the order of rotations won't impact it that much, I'm hoping, at least for the calculations that we're doing here. We're obviously bringing it to seconds, but then we're bringing it back to 1 frame. So the values are going to be close to what it is that we actually want them to be. And indeed, for just a normal hand rotation, this is spot on. So I'm actually quite happy with the simplification that I've done here, and I'm going to leave it there. But yeah, I have a feeling that when we apply the torque to the hand is correctly moved to where we wanted. Then suddenly, we obviously get our 20 kilogram box attached to the hand. The physics then handles that one, that gets it. And the momentum that the box then gets is translated back to the hand being much lighter than the box. And that is, creating our whole stressy rotation thing. So what I'm planning to do there, but I'm not going to do that in the stream tonight. I'm going to take some good time to really think about how I'm going to do that, is I actually want to create a system that as the hands pick up an object, and again, we need to also handle two-handed objects at that point in time, is that we're going to transfer some of the logic over to what is being held. So we're going to increase the dampening at that point in time. We might do something like get the weight transferred to the hands instead of to the object. I don't know yet, but see if I can get it to a point where the object actually behaves nicely when the hand moves. And obviously, if there's another thing attached, and another thing attached, and another thing attached, there will be limits to how much we can do there. But at least, you know, we'll figure something out there. But I don't want to do that tonight. Tonight, I actually want to work on something else. Well, I want to do a little bit of cleanup, and then you know, submit this to GitHub and just get this bit merged as, you know, one more step forward to because this logic is better than it was before, even though it's not perfect yet. But yeah, we'll work further from that point. All right. So, all right. Where was I with this? What you forgot what it was that I wanted to do cleanup wise. So we got all that working. We got all that working. We got the drop and teleport things. We have a max force, so the fall off. So I did add that in, or did I remove that? No, I did put that in. So we do have a maximum force that we can exert. And again, I don't actually really think this is gonna do that much. But instead of the force just stopping at that max, I've got a bit of a fall off calculation going on there. Actually, I want to refresh that. That might make a little bit of a difference with the hand movement. Oh yeah, now I remember what I wanted to do. I wanted to make sure that the ghosting hand logic is improved, because I think the ghosting hand was showing up way too quickly. All right, so we're basically saying if we move more than half a centimeter, yeah, I think so. We want to make it more. Well, that should be enough. But I want to add the degrees bit more. I actually didn't realize that I had already put that bit of logic in, because I thought I hadn't made that yet. The other thing which is really interesting is I go to Quaternion and then angle, and I actually wonder, can't I just get the angle from the base? I don't think so, because bases also has scale. And yes, I'm still on dev 7, so there's still that bug in there that it doesn't go to the proper part. Yeah, because I need the angle around the axis. So using the angle that I'm getting from the Quaternion is good enough. Is that ever going to be? No, that should always be a relatively small angle. Probably. Yeah, I'm actually pretty happy with that. Oh, that's the other thing which is new for those of you who do not follow my socials. My headset looks a little bit different. There we go. I bought myself a nice little Halo attachment for the Quest. So that's a Bobo VR. And yeah, that means that I've got an extra battery on it. It'll last a little bit longer. So... but the real nice thing that I like about it in this hot Australian weather, it has a little fan, and that's working really, really well. So let me put that on. I do think this is the downside of this. It is more work putting it on and putting it off, and that's the only downside. It's, you know, I love that as far as playing games is concerned. But developing, I wish it was easier to put on and take off. Right. Anyway, now, okay, that's good because that's the right version for that. All right, so now I can move my hand a little bit more aggressively before we start seeing the ghosting, and it only stays for a little bit. So that's still fine, but then yeah, our problem that we haven't solved is how bouncy this is, and especially when we move, then things go completely nuts. So yeah, that is not how I want it to be. But I haven't got a fix for that just yet. There we go. So what I actually want to work on today, I actually need to move back a little bit for that. What I want to work on today is when we touch the object, you see that it can actually get stuck sometimes. Yeah, there we go. I want to improve on that. I want to make sure that the fingers actually react. So we've got obviously our fingers reacting on our buttons. That's part of what's in the SDK. Now, if I put my controller down and I just use my hand, just have to wait until it figures out that I'm no longer holding the controller. Come on, you can figure that out. Did I disable something in? I might have disabled that. I must have disabled that in this game. Okay. Might re-enable that in a minute. Just means that the data source for controller or for hand tracking isn't enabled. But yeah, I want the fingers to actually interact with, whatever I touch. And for that, we're going to make some interesting choices. Oh, I first need to quit. No, let's keep that. Go. And we'll see also how long my battery lasts on my new headsets, because it will keep on running. Unless if I keep remembering to turn the fan back off. Okay. So I'm happy with that just being 15 degrees. That did look a lot better. So I got this idea from one of the posts that someone did on the physics server, where someone has a video, and I forgot to get the link because I actually want to put the link in reference here. But what they did was they had a avatar, full body avatar, and this wasn't for XR. This was for a normal game, and they've got the avatar completely animated, right? So you use your joystick to run with your character, and it nicely has a run animation. And when you turn, it nicely has turn animation. And when you do things, it's all pretty good. But then when you hit something, or you encounter something, the character just stops, just like we kind of have with our hand. The moment that we there we go, that our hand touches, nothing happens. Our hand is rigid and it just stops. And what you really want is for your hand to sort of, stretch the fingers. And what he did was he had that avatar with the complete animations going, but then the actual avatar that he was showing was a copy of that, with the avatar completely set up as a rigid, not a rigid body, as a ragdoll, and he was applying basically kind of what we're doing with our moving our fingers and everything like that, or sorry, moving our hand. They're applying forces to every joint to make sure that the avatar conformed to what the animation was playing. But of course, if the avatar encounters something that it can't move there, then the movement stops. And we should be able to do something similar here with our collision hand. Now, the nice thing is we already have two versions of the hand, because I'm always adding the ghost hand and I'm adding the normal hand. And right now, when they get created, over here, I'm adding modifiers to both hands, and therefore both hands are doing the same animation. So the idea that I'm having is to only add the modifiers to the ghost hand, and probably also, eventually I want to do hand posing as well, do that to the ghost hand so that the ghost hand is properly posed, but then have the main hand be done with physics bones. Now, for that, it's also important that we're already building, the bones for our fingers. And what we're currently doing is we're doing that through our skeleton update. So that obviously needs to go and get changed. That instead of that, we're actually going to be using a ragdoll. Anyway, let me first start before we get too far off track. Where am I? That is in. I think it's in tutorials. Yes. Well, let's first make sure that our changes that we have here, add-on / Godot XR tools, status. Let's improve hand movement. Okay. Oh, that's interesting that I, oops. Okay, well, I guess I did all my changes on the branch that I shouldn't have been doing my changes on. I'll just rename that branch, that's fine. But for this one, it's okay. So improved hand movement. I think I'm gonna end up with like 20 improved hand movement branches as we slowly work in improvements. Although maybe I will add this all to that one, but I do want to start with, ooh, I need to double check that. That's all changed. Oh, that doesn't show that. No, it says. So that UID is going to be something that it shouldn't be. So let me have a look. There we go. Okay. There we are. Okay. So the thing that I'm looking for, and actually I can do this here. I didn't need that other window. Oh. So I need to go to that node shader. Where are we? Shaders, node shader. 54, XR2, 1, 2, 3, 4, 5, 6, 7. I only want 7 of those. Oh, you idiot. Now I can do it. XR2. Oh, it's not even referenced anywhere. Oh, that's interesting. Ah, well. At least it's not going to complain about my UID now. I've got a rule in XR tools that I am prefixing all UIDs with XR2 because we have a whole bunch of classes that were copied from XR tools 1, and therefore they have the same UID in XR tools 1 as they have in XR tools 2, which means that if you are trying to convert your project from XR tools 1 to XR tools 2, everything blows up in your face. So that's, yeah, that's a little thing. Okay. Let me double check because I'm really surprised that ghost material where is that stored? Hands GLTF. Unshaded. Okay. So strange. I was expecting that one to complain about the UID in there. That might actually be an because of I saved it as a proper material, so it's not text. I might actually want to change that. Let's do that before we do anything else. So this material, I actually want to say save as, and we're going to make that ghost underscore material trace. Save. So saving it as a trace file. Where are we? Hands GLTF. So when we look at the material file, it can't open it because it's a binary file. And when I save it as a trace file, we can actually look into it. And then obviously our UID is now readable. And for this, I like everything to be text because when we export our project, Godot is going to export the binary version anyway, but at least this gives us proper change logs in VCS, sorry, in Git, and we can track our changes better. So that means that we're going to, I think this is the only place where we're using it, but let's just be safe. Yeah, that's the only one. So this now becomes material.trace. There we go. That should now still be working. And that should mean that I should now be able to delete the original material. There we go. Cool. Okie dokie. And with that, oops, wrong thing, let's focus. Look at that, they are all changed somehow. But delete that one, we add that one, very good. Amend. There we go, improve that. Now, I'm going to push that to GitHub so that at least I don't lose my changes. And now, obviously, this originally was my branch for my rigid body based character. I did save the changes for the extra tools itself, but I did not save the changes for this. So yeah, I'm going to have to go and rename that branch. So test rigid body is going to become improved and exactly. And let's just demo improvement. So that at least means that I will be able to merge those in later on. I'm not going to merge anything into master just yet. Well, I will add our further changes here, but at least I've safeguarded so that if we screw up tonight, then I can still go back. Alrighty, so let's go move that out of the way. I don't need you at the moment. Excuse me. I just had dinner before we started, and I'm feeling it. Okie doke. So let's first have a look, and we're going to go through here at our Ragdoll. And then the most important part is our bone simulator and our physics bones, because we are going to be we are going to base things on that. Now, yeah, we're actually going to keep on generating stuff. That's always a smarter thing. And the thing that I do not know, because this is one of the problems that I do have, and I don't really like about how this works. And it is that I think physical bones need to be a child of the skeleton. Now, we don't need it to be physical bones, because all that physical bones really do behind the scene is create a joint in the physics engine, but we bypass the joint nodes. We do that directly and have the extra logic to then apply it to the skeleton. We can do that ourselves. We don't have to do that through this. So, so we can simulate this with just normal, bones and joints. And I think that is how we're going to go and approach this. Because we already have our logic in here. If I can find it. Is that on our skeleton update, we are going through our skeleton. If that is, let's see, is that every time? This is all the positioning. Yeah. Yeah, so this updates the positions of the bones. And instead of actually updating the positions directly like we're doing here, we're going to be changing this to the joints being updated. But then over here, that's clearing them. Where do we create them? Right. We actually create the bone here if it's missing. And what we're doing here is we're actually creating collision shape directly on our rigid body, because remember, our collision hand is a rigid body, and that needs to change. So now we need to change this to saying we're going to create a new rigid body for the digit. We're then going to add the collision shape, and then we're going to add a joint that we can use to animate it. And then instead of this, we're going to go and apply that to the joint. All right. Now, before we do that, we're going to make a little helper, because yeah, we need to figure out what the constraints should be. Normally you would obviously set this up in the hand itself, but I don't really want to go down that path. So let's take our left humanoid. We're going to inherit that. And I'm actually going to be using, for now, is it here? No. Where are you? Oh, because I need to be in 3D. I'm in the wrong thing. So, we want to do that to try and test it, because we can't really test it in yeah, let's maybe do that. So I'm going to go and save this scene in the root, and I'm just going to call that test, just so that we have it. And then I'm going to create a physical skeleton here just to see what that looks like, so that we get a bit of a feeling about what everything is and which ones we want to do something with. Because we're not going to animate all bones, we're just going to be animating the bones in the fingers. And that's actually a good one, because that means it's, because we're going to have to feed that back in. Do we want it for all bones then? No, we're going to have to copy those from the other side. Okay, yeah, that's fine. Because the biggest thing is going to be figuring out how much we're going to constrain something. And that's going to be a bit of a challenge. All right. Okay. Okay. Let's go back to our script. I was thinking, I suddenly realized I need to do something before we can even get started. Oh yeah. So when we are creating things, update, we clear, that's fine. We have a hand skeleton. We disconnect that. Okay. Ghost mesh queue free. So we're actually going to start doing this not on the hand skeleton, but we're going to move that one to the ghost mesh. And let's actually go and put that here. Oh no, that needs to then be on the okay, hold on. No, that can stay here. But we're instead of where are we setting this? Let's go first. We're defining it there. Then that is get the transform of the given bone logo to our collision helmet. Okay, we still need that for, so we're going to have to create 2 of them. So we're actually going to, where's our ghost? Ghost mesh. So we're going to have to actually have 2 of these. We're also going to go and have a ghost skeleton because that's the one on which we apply our tracking. And that's the one that's actually our hand skeleton, which we're, that was some big thunder. Don't know if that comes across, but that was big. Yes. Okay. So here we want the hand skeleton because this is for getting the actual position that our fingers are in right now. So we're going to keep that. Then update hand meshes. Yep, we're going to go and duplicate that bit. We're also going to do that for ghosts. Actually, no, we're only going to do that for ghosts. So because I don't want the skeleton update on the main hand. I want that purely to be on the ghost hand. Now, one thing that I don't know is whether that is still going to be applied even if we are hiding our ghost skeleton. So we have to make sure when we hide our ghost skeleton, we are hiding the mesh, not the whole thing. And I think that should be enough to make sure that our skeletons are still being updated. Because again, we're gonna abuse our ghost mesh for that purpose. So here we got our hand scene. We do want to get our hand skeleton. We are no longer doing this bit. So I'm just going to go and comment it out. We'll remove that eventually. Okay, then we're going to go and put that here. So that's going to be our ghost. Okay, perfect. All right. But it also means we are no longer adding our modifiers to our hands. Although that's also an interesting one. Are we going to create a hand modifier that is actually going to get our base positions? Don't know yet. Okay. So in this case, we're going to go and use our ghost. So this is all going to be using our ghosts. Okay. Get that anywhere else? Let's look at that. That's good. That's good. That's good. All right. So that means that now our yep. So now we are going to construct all our things from our main thing. So here we're just going to do That's all good. Happy about that. That's just positioning a collision node, and really at some point that needs to be a better shape, but I'm not too worried about it. And then we're going to say if it's any one of our fingers, intermediate or distal, why are we not doing this? Really? Oh, yeah, because I'm doing metacarpal, proximal, distal. So that means that I got our thumb, index. So those are all the bones that are actually where we want to have the animated collisions. So yeah, that'll work fine. Okay. All right. All right. So. All right, so that's now a dictionary from the bone name and our collision shape. We're going to change that. I need some more water. So I need to create a struct for that. Do I already do structs here? I always forget the order. Here we go. Yeah, we already have that. So, oh, that's an enum. Well, we're going to assume that we need to do it there. That's always where GD_lint is a bit confusing. I never know what the actual order of GD_lint is. So we're going to create a struct for that, or class actually. Joint. Actually, we're going to call that finger joints. Why not? Class finger joints. All right. Boom. And that's going to have a body. That's going to be a rigid body, 3D. We're going to have a collision shape, which is going to be our collision shape 3D. Oops, 3D. And we are going to create a joint. And for now, we'll just use a generic 6-dot joint. But we might want to be using something else. We'll need to figure that one out. Actually, let's actually for now create a pin joint. I think that's also what this is by default, isn't it? Oh, of course, the first one is never going to be one. Yeah, by default it's a pin joint. We're probably not going to stick to a pin joint, but for now we'll create a pin joint. Actually, in here, I might just make that joint 3D so that it's easier later on to do that. Really? My memory is so bad? Yeah, okay. I'm working too often in C, I guess. All right. It has forgotten what I was having in my search before. This one. Okay. And with that, we're going to change this to a finger joint. Yay! All right. Yes or no, because we haven't changed that yet. All right, so here we're going to go through that. And then obviously here it's going to become finger joints. Finger joints is that. And now we need to do if finger joint dot collision shape. Ding, ding. We're going to go, and that's actually going to be from, and we're actually not going to, no, we're not going to care about that because that will automatically disappear when we actually remove our body. Oops. We'll also try, because the collision shape is going to be a child of the body. Finger body. And we're actually going to start with removing our joint. Oops. And of course, that's why it didn't work, because I was doing the wrong one. All right, so we're first going to remove our joint, and then we're going to remove our body, and that will also remove our collision shape. Cool. Should work. And that gets cleared. Perfect. And here, if we have it, so in this case, that's no longer going to be like that. Yeah, that's going to go and work differently. Okay. So, finger joints. So in this case, we're just going to position it because our root joints. Yeah, that's just gonna be set the way that it should. So in this case, it's just going to be transform becomes that, and we're not actually going to keep that. Cool, sweet. Okay. And that should be pretty much that transfer, because that's our root transfer. That should pretty much be stable. That shouldn't really be moving. So we're not going to be worried about that needing to be adjusted by a joint. But here we are now going to say that, hey, we have our finger joint, so we're going to assign that. And that also means if we have a finger joint, then obviously we're going to go and do something. But in this case, if we don't, we're going to do something else. And we'll deal with that in a bit. Okay. Okay. Check that all later. Cool. So with that, we now need to start changing this, because we actually need to create a few different things. Cool. Oh yeah, we have our default origin adjustment there. We don't actually need to do that way anymore. So that's I'm going to remove that in a minute from the other place, and then offset, and then that, so that becomes new. I actually want to go and do that here. So here, finger joint becomes finger joint. Can I do it like that? I think so. All right, cool. Then finger joint dot body is widget body 3D dot new. And obviously we're going to have to get some nice in the default settings there. But for now, I'm just going to leave that as is. That means that our fingers are all going to be a kilogram. That's going to be funny. Actually, let's unset that first because we want them to be really light. So our normal hand weight is 0.4. So eventually we'll have to have a finger mass here. And then we're going to have to do a calculation so that all adds up. For now, we're going to just leave that there. So we're just going to say finger joint dot mass, dot body dot mass is, let's make it really, really light. Like this, you know, our fingers, we really don't want our fingers to make any difference in our, in the way things work. All right. And actually I need to move this to the top here. I'm going to go and say finger joint dots. Okay, I call that collision shape, but I really want to call that collision node. Actually, let's just call that collision. That makes much more sense. Which means, oh, here we already get that, so I'm not worried about it. And then we're already here. Okay, cool. So finger joint dot collision is new collision shape. Finger joints dot collision dot name is that. Finger joints dot collision dot shape is going to be that. Very cool. And here we have, oh, obviously that needs to be at the top. There we go. Obviously here we also want to do finger joint dot body dot name is going to be bone plus body. Okay. Now finger joint dot at child is going to be finger joint dot collision. Perfect. Here at the end we do that. Okay. So we're going to add that to there. Now boom. All right, so we're going to add those two, but I'm actually going to comment that out and duplicate that. Let me double check. Is this a tool script? No, it's not. It is a tool script. Yeah, it's tool. Is this running in tool? I don't know. I think it is. I'm not sure. Okay, so that's called from here. And then it's kind of called there. Okay, cool. Yeah, so that is always executed. All right, then I do not want to add them that way. That would not be a good idea. We need to make sure that we're always adding them as internal nodes. And I'm actually kind of thinking that we might skip on this if we're in editor, but for now, we won't care. All right. So adding that, we're adding that. And finally, what we need to do, finger joints dot no. That's actually going to be some slightly different. We're going to start with making that a pin joint. Because remember, we in our struct, we're just making it a normal joint. So we can use any type of joints in this. We might even mix and match at some point. But for now, I'm just going to be using a normal pin joint. And that just means that we're only having rotation. That's fine. Okay. So. All right, this is going to be interesting. Because the other thing that I want to do, and that's one of the reasons why I did that, is I want to make sure that this is going to be positioned, but I'm actually going to position the body now. There we go. And I probably actually want to do that here already. So our initial transform is being set here. All right. Cool. This is the other thing I suddenly realized is that I think the, excuse me. That doesn't really matter. The skeleton update is being called once the skeleton is fully positioned, which actually happens in our process. So our physics has already run. So we're basically setting this up for the next physics frame to actually do something. So actually, I'm going to go and put a class in here. And that means that one of the things that I want to do here is transform 3D. Okay, cool. So we're actually going to go and we're going to set that. Oh, that's why I always wanted to have the offset. No, actually, I don't need the offset anymore. That's right, because this is now actually going to be the transform that we want the joint to be at. And the physics body is going to move with that. So, pin joint, we're going to have that. Is new, oh, sorry, pin joints, 3D. Yeah, I'm going to create a new one of those guys. Sweet. All right. It means that here at the end, we actually can assign that. But we now also need to add that, add child, and body, nope. Sorry, finger. No, we can just add the joint here. No dots. No, back. Okay. So one thing that is really important is that we add the joint first, and then we say joint dot node A is finger joint. Now this is actually going to be our cells, so that is get path, and then join dot node. No, it's actually not that one, because this is going to be in order. So we actually need to figure out what our path is. Okay. So this is going to be our finger joint dot body dot get path. There we go. Parents node dot get path. We don't have that yet. Actually, let's call it parent body. All right, so we need to figure out what a parent body is. Cool. So, var parent body widget body 3D. We're going to start with assuming that it is us. Get parent. Cool. All right. But in case it's not, parent bone is yeah. Ghost skeleton gets bone parents. For this one. All right, cool. All right, if parent bone in 0, because we don't want to do this for our roots. Let me say for parent bone name is ghost skeleton dot get bone name parent bone. Now we're handling them in order. Hey Dave, how you going? Pretty good. We're trying something funky here. It's going to be interesting. Actually, that's the other thing that I'm going to do is it's going to be horrible, but I'm going to put visual collision shapes on so that we can actually see what our bones are doing. All right. And right now it should be really floppy in because I'm not yet going to animate them. I'm just first going to create these things and I'm not going to do anything. They're just going to wiggle and wiggle. It's going to be cool. All right, so we got our parent bone, very cool. And what we now can do is we do them in order. The ghost is just a ghost hand, but what I'm doing right now is because I want the main fingers to be controlled like a ragdoll. I'm using my ghost hand to position the fingers so that I've got all my finger animations working, and then I'm applying that to the ragdoll. But I'm creating the nodes for the ragdoll logic, and the ragdoll's a bit of a misnomer here, but I'm creating them from the ghost skeleton because I need to loop through it anyway, and we're just going to go and do it that way. Alrighty. Okay. Now, one other thing that I'm still wondering about is, yeah, I don't think I care. Yeah, we're just going to go and all right, that's the other thing. I actually need to disable the not being able to see the ghost hand. Yeah, I was wondering if I should position the bones in the actual hands for display in their skeleton update, or if I'm just going to copy when I'm ready to copy. So I don't really care about that. Why don't ghosts and skeletons ever argue? All right, I'll bite. Why don't ghosts and skeletons ever argue? Because they always see right through each other. Yeah, that works. That works for me. Yeah, so if we have a parent bone already in our collision and I'm going to rename that. Parent body is parent bone name dot body. And now we get the path, we get the joint, we get a new joint here. Joint dot name is bone name joint dot transform is going to be bone transform, so that's going to actually be where it needs to be. That's just going to be our starting point. Yeah, it's going to be actually kind of interesting because I'm actually might end up regretting this. But I actually want my rigid body to have that bone transform as well. And instead, we're just going to offset our finger joint collision. Okay, because the problem that I suddenly realized, the transform of the joint doesn't matter. The only thing that matters for the joint is that at the moment that we are adding these together, yeah, because I think it's the relative position between the bodies that is being used here. And I think the actual position of the joint no longer matters. Might not, which will mean that our fingers are going to be completely disjointed. We'll figure that out. Because else we're going to have to add our joint as a child to the parent body. But I don't think that's the case. I think, and this is one of the things that I find very irritating about the physics engine, is it's always about the relative position when the joint enters the tree and the nodes are assigned, which is why I'm adding the joint first and then doing these things. So it's going to be interesting to see how that works. But it also means that we're going to be applying that to our rigid body, which is why I wanted our rigid body to be at that center point, because we're just going to be applying our torque calculation. It's all that we're going to do to make sure that our rigid body is going to be positioned the way that we want. Now, the other thing which is going to be interesting is that for this to work, we actually need a difference in orientation between this and its parent. So I might actually want to store the parent bone. Yeah, I think I'm going to want to do that. No, no, I'm going to keep it to this. So it's always going to be in the because all the rigid bodies are going to be oh, that's actually a good one as well, because they are right now children of the hand. Does that matter? Because I might need to make these top level path as well. Or am I going to? Because they're children of the... Huh. I might actually need to add these to the parent of... Ooh. Huh. I hadn't thought of that. Is that going to be a problem? Because as the hand moves, that body moves. And because the other joints are children of that, they move with it. And that might screw up our physics simulation. I'm going to pretend that that's not a problem for now. It might be, in which case one of the other things that I'm thinking about here that I may need to do well, they're pin joints. You know what? When we add these, that is added. I'm actually going to say top level is true. Because we are going to go and create that joint. That joint no longer matters position-wise, as far as I'm aware. So I'm not going to care about the position of that thing. But because they're now joints, that's going to be fine. Because our collision hand is top level as well. So I think that'll be fine. But that obviously means that that one needs to be applied in the global space of our finger. And that's fine. Because again, we're only going to be dealing with rotation at this point in time. We're not going to deal with positioning for now. And that's, I think, is a big problem here because, like I said, I cannot, as far as I'm aware, I cannot adjust the offset of these nodes after it's created. So if my tracking data actually states that my bones are longer or shorter, that's not going to work. Quantum entanglement, okay. So that's going to be interesting for reapplying it. Now, in this case, it doesn't really matter because we're working... No, it does, because we do get a finger... I'm going to figure that out later. I'm not going to worry too much about that. But I think right now, this is going to fix the bone length. And that's actually fine. We're just going to... For now, we're going to pretend that that's okay. But I think there's going to be something that where we are going to need to have the joints extend or shorten. Oh, well, it is what it is. Okay, so I'm happy about that. Everything is created. Everything is stored. Storing that. We're not doing anything with it. I'm happy with that. I'm going to pretend that I'm not going to do anything with that. That's good. Okay, so ghost mesh. That's fine. just going to make this always visible just for now. So obviously I need to remember to undo this. I'm probably going to forget. We will see. Okay. So with this change, our ghost hand should properly move our fingers around. Our real hand mesh is no longer going to move the fingers because we have no more logic that positions the fingers of the normal mesh. But we should have bones and joints created for our fingers with pin joints that we don't position. So they're going to nicely be dangling. But I've got collision shapes visible. Also want to deploy with remote debug so that we can actually see that. So let's see if it does something that looks half right. Okay, I need to restart. Steam Link. Okay, there we go. Let's see. Whoa, okay, we have a break in our code. Okay, transform. What did we call it then? Oh, what did we call it? Target. Okay. Target. Continue. I just changed that, dude. Yeah, there we go. Okay. All right. We're getting lots of collision things. Obviously, our hand is no longer being positioned. That's correct. But I don't see any of the collision shapes that I was expecting to see. So, not quite sure why. Well, I can see some of them, but they're definitely not in the right position. Okay. So this is one of the things that I don't actually like about the new collision options is those red triangles that you saw. They're to visualize where there currently are collisions. And I only want to see the shapes. I don't want to see the collisions. So yeah, there is definitely that. Now the other thing that we can do is we can have a debug caller here. Just want to have a look. Oh, crash. Yay. I hope I didn't lose anything there. All right. We're back. I was looking at the collision shape color. So I'm actually going to want to have something really obvious. Maybe something like this. And then here, finger joints dots collision dot debug color. That. Okay. All right, might want to do that. That actually does show. I actually need to do color. I think it's like this. That I can add the code in. Not sure if the pound sign is needed. Might not be. Let's actually quickly see. Does it say that? No. You know what? I'm just gonna go do this. Not muck about with it. I want that almost not transparent. Hopefully that will be visible a little bit better, even though we get all those funky triangles in there, which I'm not happy about. Okay, now. Pinjoints. Well, exclude nodes from collision. That is by default, so that's good. But there's no, oh, hey, parameters. There's no, on a pin joint, there's no constraints. That's why I'm not thinking that pin joints are actually what we want to be using. What we actually want to be using is a, do you want to use a hinge joint? No, that's only going to limit in one, in one direction. So we don't want to limit there. And then here, the angular limits. These actually need to be set. Because by default, we won't have a movement in there. So I'm already going to change this. I want to make this already generic 6dov instead of pin joints. We're going to leave everything default. And then we're eventually going to start working on, okay, how much. And you know, the thing is, I'm happy for the fingers to move quite a lot. Right now, they won't move because there's no upper or lower angle limits. Yeah, we'll see. Okay. Let's just see what this does. This is the downside of doing everything by code. It's hard to visualize what it is that we're doing. Okay. But with the generic 6dov and default settings, I was not happy about that. Wow, it's colliding with something. All right. We need to copy some settings because we are actually having our fingers collide. Okay, so we actually need to copy a lot of things from our parent onto our finger joint body. So let's start with finger joint body dot. Let's actually go here. Go here. Oh, we're going to have to do contact monitor as well. But we're not going to worry about that too much right now. But we eventually want to make sure that that we know when our hand touches things, and obviously that's something that we still want to do. So we're going to have to copy all that. Don't care about that. Don't care about that. Don't care about that. Probably want to copy that over. Okay. But the things that are important are these things. So collision layer. Collision layer. We're just going to copy that from our parent collision mask. We're going to copy. All right. And now here comes a real big problem is I really want to copy our exceptions or collision exceptions as well. But what to do when there are additional collision exceptions? So at some point I need to start creating a collision exception handler. So we're going to make a remark here and say to do, actually I'm going to go and put that over here. Enhance this so that it is updated if things change on our hand. For now, we simple. All right. Now, and one thing that I really find interesting and somewhat annoying, which I need to get it here. I need to get it from here. No, even one more back. This one, I think. Yeah. Or not? No, it's not on there. Yeah, add collision exception. Is there a way? Get collision exceptions. All right, cool. So hopefully at this time our collision exceptions are already set. Yes, collision exceptions. And that's going to be, what is it actually returning? That is returning an array of physics bodies. Cool. So I can actually do that. And now I can say exception dot add exception with finger joints by body. This is the annoying thing. We need to go both ways. Add collision exception with. So yeah, we need to create some sort of manager for this, because this changes over time, and we need to make sure, because we have our collision exceptions for our body, that our fingers always have the same collision exceptions in the same layer. So that is something that we're going to have to manage and work through. That's just for fun, just in case. If is valid, it's valid. Oops. Exception. Just in case there's something in there that's no longer valid. It shouldn't be, but you never know. So yeah, we need to make that much better. But hopefully that will do enough to at least stop our thing from going haywire. Okay. There we go. Okay, so that's still, no, it's still colliding with what it shouldn't be colliding with. How great is that? It's going absolutely nuts. So is there anything here in our debugger? Actually, one of the things that I'm thinking about is this needs to go at the end, because we don't have a path yet if we do this too early. That might be the reason why that didn't work. To do make some sort of sections. Although we can probably create, I'm not even sure if that's possible to override. I don't think that's a virtual function. So I don't know if we can make an override function for that. All right. No, we can see that we're still colliding with things. Why does it do that? That makes no sense. Okay, we do have hand tracking, which is nice. I am not positioning. Okay, one reason this might be that I suddenly realize we've added weights to this. So what we're going to be doing now is we're going to add a new helper variable. Finger mass. Oh. I wonder if we're having the same problems with our boxes, because we now have these you know, our moment of inertia is now just our just the main body of our hand. Because we no longer have collision shapes for our fingers. Okay, hang on. I need to try a few things. That's good. Okay. I'm just going to disable creating a bone. So I just want to see if that that makes a difference or not. Okay, so indeed. That's actually really interesting. Because I think that also means that our collision shape for our hand has always been incorrect. Maybe. Okay. Or are we not positioning this now? It might not be positioned anymore because we create this the first time round. And maybe it's not yet got its tracked information until later. So okay. If bone name left hand, right hand, then offset is that. Collision shape transfer is that. Okay, something that I want to do here is else if and skeleton and skeleton dot set. Is it global pose or is it pose? I think it's pose. What are we using here for getting? No, global pose. Transform. So if it's not something that we are managing through our collision shape, we're going to go like that. But I still think that all this time I had my my central one wrong. So that's going to be interesting. Okay. That also means one of the things that I want to change is in here, just so that we can see things better. I am going to go and give our hand, no, a new material. White is fine, but it needs to be transparent. And we're just going to make that nicely. So now we have the blue one to see what we're tracking, and we have the white one for the actual one. And hopefully we can actually see our collision shapes. But hopefully that'll tell us a little bit more about, well, obviously we're not creating all the collision shapes right now, but hopefully that will tell us something more. Okay, that did not work. Oh, that did work, but I only did it for one. And I definitely want to make sure that my collision shape for my palm is a different color. But also, obviously, our global positioning doesn't work because it should be positioning all of them on the hand. So that could be that we need to use the override one. Set the of the bone, and bone is to rotation. Rotation is no bone rotation, no bone transform. Okay, that's deprecated, so we're not going to set the global pose transform pose for the bone. If other bone poses have been changed, this method executes a dirty pose recalculation and will cause performance to deteriorate. If you know that multiple bone poses, considering set bone pose. Set the bone position of the bone that to position. Position is vector 3 describing the. Now I need to do a whole pose. Where is the set bone pose? I think we might just need to copy that normally. So let's indeed do that. So we call that T. Bar T transform 30 is post skeleton dot get bone pose. Just copy. Okay. Right. Take that out. store this so we can what's its key. We might even I'll figure that out later. Because I do think we need to know what the parent is at this point. We'll figure it out. Okay. Okay. The other thing that I wanted to change, actually, we might make that a new group here. Physics appearance. And what we're going to do here is export var debug color is color red 0.9. Really? Actually, let's also quickly go and do a copy here. Let's go and paste that here. Not there, here. So that both hands are now white. Now let's just go and reopen that because that's the way to get our new one. So there's a new debug color. Cool. We actually probably want to have that value is debug. No, the other way around. Oops. That was dumb. Okay. Here we can use nice ifs because if we don't have them yet, they won't be there. Debug color is okay. Let's also go and wherever we can just search for that. There we go. We got a view equal debug color. Do the same thing here for when we create our finger joints. And now that should nicely copy it over as well. And if I really want to be anal, all right. Shame that it's not showing my internal debug shapes here. And I wonder if it's actually not doing that here either. Which might be the reason why. Okay, so it's hard to see, but it is there. And it is orientated wrong. Although that could be because we're actually not positioning our hands correctly yet. I'm not sure. What is going wrong here? What is going wrong? I don't know. I don't know. All right. At least we can see those. We no longer have our fingers right now, which is fine. So Okay. One thing that I'm going to do right now is I'm going to do this. Hey, Angus. And I'm just going to do that with one hand for now. That's the other thing, is that we're going to have to react for that for our fingers as well. And say if our mode is non or teleport, then obviously we're not going to do our actual finger position. We're actually going to all keep it in one place. All right. Let's see, because all that I've done now is I've actually disabled that, and that means that this should just be moving along. That's fine. But it's still not in the right position. Okay. Now I'm going to do one more thing. This is where it's good that I haven't removed code yet. So with the left hand on teleport, that means that none of our further logic is being run. And it should just be positioned. So in our update, no, skeleton, what we're just going to do for now is I'm going to comment out that one, because I do not want to update my hand skeleton right now. And instead, I'm going to add this back in. Not this one. No, what? No, sorry, that's the wrong one. I'm going to add this one back in. So we're going to add our modifiers back to our normal hand, which means that a normal hand should be animated the way that we expect it to be. Again, I was expecting that. Oops. Okay, so now we can see that that is actually positioned correctly. And interestingly enough, our collision shape is now positioned correctly as well. And that I do not get, because our collision shape is being controlled. All right. So let's remove our hand modifiers again. We're not doing it there. Ah, that's our mistake. Yeah, that's not going to work, is it? Okay. So let's see. The hand should be wrong now because I've disabled some of that logic, but our collision shape is now where I'm expecting it to be. So it's hard to see the collision shape there. I wish I could make the lines that it's drawing bigger. Okay, so that was actually working. We were just reacting to the wrong skeleton. Oh, that explains that. So now, with getting this back into shape, our hand should be positioned, but our fingers, well, actually, everything should be positioned correctly, because I haven't updated that yet. Okay. So our hand is nicely there, and because I'm doing everything now, that bit is working. Okay. So let's start with one set of digits and see how that works. All right. So what I now want to do, take this back out. We're going to go and do this and this. And we're just going to do the proximal bone. Okay. let's see how much that screws up. So if we have, oh, we don't want that slash in there. We just want to go like that. If we have a proximal bone, we're going to see if we have a shape already. If so, we're going to use it. Else, we're going to set up that finger and join that to the hand. All right, well, those fingers are definitely in the wrong spot. And what we can see is that now we get that same funky behavior as with the as we had before, because our momentum is no longer what it should be. All right, but why are the finger bones in such a dumb position? Okay. That means no change. So that I'm happy with, I think. But this should be positioning the finger properly. Okay. One thing that we're just going to do here now is for debugging. Sphere mesh, new sphere radius is 0.01. Height 0.0. Actually, on that 1 and that 5. For instance is mesh. Instance 3D is mesh. Instance 3D.new. Instance.mesh is sphere. Finger joints. No. Joints. Add child instance. Okay, so I'm just putting a sphere where my finger joint is, just so that it's easier to see where things are placed. So obviously that is already bone transfer when it was created. We add the body, we add the child, top level assign. Okay, let's just see what that does so far, because now we should see at least a sphere where our thing is. Okay, so that is definitely over there. So why are they not in the right position? That makes no sense. Okay. Why are they in the wrong position? All right, hold on. Get bone transform. Get our global transform. Perfect. Ah, because we have our orient to Godot. So why did I not have that problem before? Unless phone transfer is not there. Why is that important? And is that something specific to what we're doing here? Or is that something weird? Because how did my shapes get created properly before? That's the thing that I don't get. Because this would all suggest that all this time my bones were in the wrong position, but I remember checking that when I built this. Huh. Huh. Well, let's assume that that is in fact correct. Although no, it just doesn't make any sense. Because I remember that final orientation was just to orientate the node just in local space. So that shouldn't be having any effect here. Why would this be? I'm just going to do this again, just in case it changes when it's a local space. Maybe there's a problem with that. I don't think so. I don't think that makes a difference. No, that makes no difference. So why are they there? I don't even know why the rotation screws up, but that's okay. I know that that doesn't make a difference. Let's, for fun, get both of these. I just want to see whether they will be in the wrong spot too. Yep. Interesting enough, they are colliding with something. I don't know what. Why is that one going right? And are these all going wrong? I think that might be you're all colliding. It doesn't make any sense that you guys are colliding. Because you should have collision exceptions between yourselves. That should no longer matter. No, it doesn't. Why are they initially wrong? Unless the first time they are created. I'm starting to wonder if we need collision shapes for every part of this. Because the thing that I'm thinking about that is happening here is we're creating it the first frame. And at that point in time, the hand is still in its default location. Now, the weird thing with tracking in OpenXR is that the tracking data will actually rotate the hand into a given position. The root is actually not in the same orientation as the rest of the bones. And I'm guessing, and this is one of the things we could try this just to see if this is our reason. So when we do this, I'm just going to make a var testing bool is true. And I'm just going to say if testing testing is false. So I'm only going to position my palm collision shape on the first time that we do this. And I think at this point in time, my tracking data hasn't been applied yet, which means that everything stays in the default location. And of course, that screws everything up, so I can't even see what's happening. Oh, I can see it on this one because this one is there. So now we can see that our orientation is wrong. Oh, everything is actually, Oh, that's weird that it just stuck behind there. So yeah, I think that is our problem. There's one floating here. Why is that? You see that sometimes the physics simulation is just, I don't know why that's no longer updating now. That's so weird. Oh, that's because here we're using teleport. That's right. So, and our fingers aren't frozen, but our main body is frozen, and it doesn't like that. So that's obviously something that we have to make sure we do correct. But here we now have, yeah, that's rotating like crazy. Okay. Interesting. So that's our problem, is that we haven't positioned it in the first frame yet, which is fine. Okay, so how am I going to solve this? Because I need a joint that rotates along. So I need to, oh God, this is annoying. This is really annoying. Oh God, how am I going to solve this? How am I going to solve this? Let's go back to our hand. What it looks like. So, because this is where things get really problematic. That my hand node is not in the correct orientation when I create everything. So then my hand gets rotated in the right position, everything else stays there, and I can't move the joints. The joints are, you know, everything is offset. It's offset when created. So what I really need is sort of like an extra center object that I can rotate. So but I can't really make that of the hand because then the hand doesn't have a collision shape anymore. Foobar. Foobar, foobar, foobar. How am I going to make this work? Because what it basically boils down to is that I want I want my root bone to be part of my hand transform. Well, it's going to go and be an exception to that, so I can do it. Yeah, we can do it. What I'm thinking of doing this is actually interesting because how does this then work? Yeah, because these are all rigid bodies. And then the position of that is brought back to the skeleton. So it's actually not the hand that is moving, which is something that we do want to have. No, I guess we could make that work that way. I guess we could do that. Huh. The thing that I'm thinking about is actually using the physical bone simulator to do this and no longer having our collision hand be a physics body. Instead, this is going to become a normal node. We're still going to position it where we want it, but what we're going to be doing is if our tracking mode or physics mode is collide, then we're going to enable the Ragdoll physics and make it work with that. And I guess if it's teleported, we don't. We just place it where it is. big question then is, what happens to the physical movement? Ooh, that's a big change. But we could make it work. Might actually be an interesting way of doing it. Now, the other thing is, can I still make my pickup function work? Can the pickup still, because again, now the collision hand is no longer a rigid body, it's actually going to be something inside of the collision hand that is the rigid body. But we're going to piggyback on a lot of logic in Godot itself. Oh, that's really interesting, actually. The thing that I don't know is this a normal rigid body? What is this? It's bone, joints, physics body. Oh, this is going to be interesting if we do this. This is actually doing... What sort of collision shape has it made for this? Capsule. Wish you could zoom in better. I don't think we can go smaller than this, but at least we can zoom in a bit. So it makes capsule shapes of all of these. It's interesting that that one isn't then a capsule shape for all of those as well. Let's go on there. Let's go on there. Let's go on there. Interesting how it gets into there. Yeah, I really wonder why does it do that? It doesn't really make sense to me. Oh, because we actually don't have a collision shape for that one. Or that one. So it's actually, it's not using the transform of the hand here, it's using that. Okay. Interesting. So I guess this collision shape is offset then? Really weirdly? I don't know. Okay. Still think we should be able to recreate exactly what it's doing here. Sorry, guys, I'm just doing a lot of thinking just to make sense of how I can make this work in our situation here. Oh, look at that. We can actually see that in because of making the spheres, you can actually see that they are created in the correct place. It's just because we don't have something here at the root that we orientate that we don't get anything. Now, the easiest thing that I'm thinking about that would solve this immediately is if we just create an extra little helper here on the root, from which we then do that, and we can actually go and orientate from that. That's probably the easiest way to do it. All right, I'm actually going to go and change this ever so slightly. What I'm going to do is I'm going to go and move that up to over here. I always forget whether onReady vars need to go at the end or at the start. Let's assume they go at the start. OnReady var, and that's going to become hand digit shape 16. Let me guess, we already have what? Preload shape. Oh, that's a different type. Okay. Capsule shape 3D. Oh, idiot. Capsule shape 3D. There we go. Okay. That's good. Back down here. Skeleton. Update. Can this be that? Cool. All right. So what I'm going to do now is I'm actually going to make a helper function for this. Link create and points. No, call it finger joints. Points. Return a finger joints. Okay, just place on private collision functions. Yeah, it's cool. All right. So that we're gonna go and move all this into here. It's going to be var finger joint, finger joint. Okay. And obviously, bone name as a string, offset as a transform 3D. Hi, Bikakina. How are you? And what else do we need? Bone transform. Cool. And I think parent body. I want as the very first one that I sent through. Okay, that's just a helper. That's fine. We're going to create all of this. We have our offset here. Okay. So, with all of those, where are we? We can say finger joints is create finger joints, parent body, bone name, offset, transform. So obviously we named them the same, so we should be able to just pass them through. Cool. I actually want to go and put this here. Boom. Parent bone. Cool. Got a bone name. We're always going to need that. And get parent bone. Returns the bone index. Parent bone. If -1, bone has no parent. Sweet. And what I'm actually thinking is to change this to say parent. Let's go. Just in case that doesn't work very well. Parent bone. -1. So if it's our root bone, we're going to go and do that. Else, we're going to go and do that. So actually, yeah, now we're going to keep that for now. That's fine, actually. What we're going to do now is we're going to create a joint for this as well. Okay. So in this case, actually, we're going to know that parent body here is always going to be self. Cool. And in this case, we know that that's always going to be cool. So yeah, that should really always be true. No, because then we need to create all bones. It's kind of fine. Actually, that means that I also always want to if parent body is not self, then I obviously want to create a exception. Don't collide. Oh. We've got fingers not colliding with their parent finger because of the way that works. So I'm happy about that. Those are just helpers for debugging. That's fine as well. I'm going to give them very little mass. Okay. So cool. That's so cool. Sweet. All right. Okay. One more thing that I want to change is that needs to become shape. And we're going to go and pass that through. That is the last one. Shape. I'm guessing that's this. So here, I'm just going to have the hand-digit shape. And here for now, I'm just going to go and say, I also want to create a resource for this, but for now, I'm just going to keep it really simple. Shape, sphere, shape is sphere new radius shape dots margin. That's already really bigger than I wanted it to be, but it's just to have something there. Okay. So with all of this, we're going to have, oh, that's right. If as phone name and I'm really wondering if I should add all bones in there, but we'll see. So yeah, that's going to be fun. All right, so now we do have a shape here at the root with just a little sphere there. And actually, I need that to make that offset 0. So let's quickly do that. So here we have an offset for my palm. That's fine. But this offset can actually be just an empty offset because I don't really want that there. Okay, that's okay, cool. All right, let's have a look and see whether that's starting to make sense. Oh, what's that? Bling. Oh, yeah, of course. My headset went to sleep, so we no longer have access. Yay! Cool. Yeah, I know. Okay, let's see if it now can reconnect. Come on. You can do it. All right, so we now have that. Oh, that's cool. Oh, I changed that back to that. Okay, so obviously now it's not in the right position because I'm not rotating anything yet. Interesting enough that this is already more happy because now we suddenly have that little helper root node there, which is really cool. Very interesting that that makes a difference. Not sure why. Oh yeah, that's correct. That's what it's supposed to be. All right. So now I need to start making logic. I think I'm going to have all digits in there, or else the simulation isn't going to do what it's supposed to do. But that's fine. And I don't really care that the collision shapes for that are not the right size. It's going to be good enough for what we need it to do. All right. So let's change this. Actually, no, let's keep that in there. However, collision hands. What I'm looking for. Oh, I wanted to look here. Yeah. And then skeleton. Tip. I want to do everything but our tips. So we have our root bone here, and then everything else gets done here. Cool. Then we're not going to bother with that anymore. We're just going to set our targets. And then obviously we need to have logic for our targets. Okay. So that means let's actually go back here in player. I want to put my collision hand here, this one, back on teleport because I want that mode to work as well. All right. Then in our update trackers, no, update hand, no, where are you? This is process. Okay. All right. That's fine. We get a target override. Freeze. Okay. Freeze. Mm-hmm. I think I'm going to need to have a helper script for that. Yeah, I think I'm going to do it that way. Okay, cool. So, I need to have a helper there because I can't override the built-in property freeze, unfortunately. Actually, I can do that completely in the helper object. That's fine. All right. Cool. So, I always forget if we need to put priority higher or lower. That's always interesting. We're gonna go for higher. Okay. Yeah. Okay. So we need a help script. Well, why not? Here's our collision hand. Here's our collision hand. So create new script XRT2 collision finger. Great. I have collision finger. That is going to become a rigid body 3D. Sweet. All right. Let's go and copy this. Now, I'm not going to give that a class name. I'm going to actually make a remark. Because we're not going to make the users like that. We're just going to use that as is. Cool. Which also means that we'll deal with that in a minute. Okay, cool. Func ready. And this, we're going to go ready from here. Gonna assume 91, but we might go the other way around. We also want to go and do our physics process here. I'm going to pause just for now. We're definitely not using our delta here for now. We might, but not yet. Dismiss. Let's make it up. Okay. So, we're going to go and make an export var skeleton. Skeleton 3D. There we go. Export var bone. Are we giving it the bone? Oh, that's a good one. I don't think we are. Come on, where are you? Here, great figure. What do we set? It was a parent body. That's fine. Bone. So we're giving the bone name here. That's fine. We'll make some nice logic here. Actually, it's a func set bone x class. Let's do set value skeleton is value. It is inside 3 Actually, let's make that update. Be consistent in the way that I name things. I'm also going to go and do that here. Actually, I want to have a int. That's one. Skeleton. Actually, if not skeleton, is this one. Else if skeleton. No. Skeleton. Get bone. All right, come on. There has to be the opposite of get bone name. I'm sure. Or is that find bone, maybe? No. Find bone, of course. Oh, but then it just becomes is find bone name. There we go. That means I can do set value here as well. Bone name is value. All right. So now we should have a bone IDX. All right, so here, if not skeleton, turn. If bone IDX is -1, turn. All right. So we now know that we have those valid. Cool. Let's just leave that intact for now. Okay. So we know that. We know that. You know what? Put bar. That's a target transfer. Which means, so here's our body, finger, joint, body, script, no, set script, preload, is this one? All right, so that works. All right. Now we should be able to say, well, actually, you know what? Let's not be annoying. Which way around do I always do that? Let's go last name first. Last name. 32 collision finger. Let's hope nobody is dumb enough to use that directly. But that means I should be able to do that. And I should be able to do that. Which then also means that I can do finger dot skeleton is and skeleton. Let's go and give that some remarks. So this is the skeleton to update bone positions for the bone we're updating. Our targets transform. Okay. Finger joint body dots bone name is bone name. And let's just target is transfer. Bone transfer. There we go. So we make sure that we have a initial value to work with. Cool. Sweet. Collision. Da, da, da. We'll eventually Actually, that's a pretty good one. We can actually make that all work in here. So we can move that over to there. That's actually kind of cool. Yeah. Okay, we're gonna do that next, but I think in here, what we can go and do is, okay, we need to get parent. So that's going to be an onReady var parent. Physics body 3D. Let's get parent. There we go. Actually, you know what? Really? Come on, wake up. Yeah, are you gonna keep working? Don't go to sleep. Okay, that was still in time. Yay. How's my battery actually? Doesn't really. There's a stupid sticker on top of it. You can't really read out the battery setting. Yeah. Yeah. Well, doesn't really matter. Let's actually go and move this into here. If not parent, so if we couldn't find it, then mink, we're gonna go away too. All right, so we're pretty good. So now freeze is parent of freeze. If our parent is frozen, we are frozen. If freeze showing a target transform. Parent dots global transform times target transform. So we need to make sure that we have our transform in global space or where we want to be. And here we're simply going to say our global transform target. Else we need to do our funky rotation stuff. Okay. And here for now we just care about rotation. Because again, if we have finger lengths changing because of tracking, we're going to get into trouble because we can't change our root of our joint. At least as far as I know. Let's actually see if that maybe I've missed that. That's part of the, no, we got a node A, we got a node B, but we have no way to do something about our offsets. That's set when initializing, and then that's it. It doesn't like it from that point onwards, or doesn't like you to change anything from that point onwards. Okay. So let's go and actually copy some things here. Pretty sure that we don't care about that anymore, so that can go. Then here, we actually no longer care about storing the target in our finger joints. And to some extent, you know, we could actually make some of this stuff work inside of collision finger, I guess, but whatever. All right. So what we're going to change instead is we're going to say body dot target transform. Cool. All right. So actually, process. So obviously our process is going to run after process is going to run after our after all our physics runs, because we're not using physics on a separate thread. We're actually in here in the process, we're going to do our copy back. So physics should have done its thing. Okay, now we don't have any guarantee of the order that we're doing things here. The meta Crash 3 model already exports the plugin to export. I'm not sure what you mean by that, Dub Club, but you can definitely export directly onto the Quest. I'm running in PCVR mode right now over Steam Link, but you need the vendor plugin. You need the vendor plugin installed for that. And with that installed, you can set up an export template for Quest, and then that will work. And I have a video on my channel that explains that whole process. So if you go to my channel and you go to videos, then there is a nice video here called Getting Started with OpenXR in Godot. And if you look at that video, there's a time code in there. It's about 2/3 through, where it then talks about exporting to Quest. And that tells you everything you need to know. Now, yeah, we're just going to go and use our set bone thing for now. See if that works. Okay. So if we're frozen, we should already have a working situation. But if not, then yeah. Okay, so in this case, what we're going to do is we need to go and get our I always forget which way around that is. So bone transform 3D is going to be I think that is going to be parent. Oh yeah, now of course I still need to have my parent here. Let's start with that one. Parent dot global transform dot inverse times global transform. That might need to be the other way around. I always mess that up, but we will quickly find out. And now we get skeleton dot set bone pose bone idx bone transform. That should do what it needs to do. Okay. Let's go and see if that works with our frozen version. But before we do that all, I'm going to go and do a little bit more work with this. Because now that we've got all this, we can actually go finger joint. We can actually start moving this away from here. And instead, we're going to do that in a physics process. As soon as we have our parent, copy some stuff from our parents. Now, in this case, we're going to be doing it every time. And I guess I could do a check around there. I might actually do that just in case, because this is nitpicking. It should be doing checks like that inside. But if not, it's going to go all through the physics engine when you assign that, and there's going to be a whole bunch of overhead there. Now, the other thing that I want to do is I actually want to go and where are we? I'm actually going to take this out. We are going to put that back in. Okay. Sync exceptions. Okay. For our current exceptions. Boom. And we can actually do that as an array. There's the body. There we go. Link. So those are our current exceptions, and I still find it so stupid that we need to do everything 2 ways. Needed exceptions. Is parents dot. There we go. Sweet. All right. Push back. Parent. So we're gonna always have an exception with our parent. Never an exception with ourselves. Good. Perfect. All right, cool. So now we're going to loop through our exceptions, and we're going to look for actually our needed exceptions. All right. And here we're going to say if current exceptions has exception, that's very cool. We're going to just take that out. We have it. Point. All right. But if our needed exception is not in there, then obviously we need to add our exception. So this is going to be an exception itself and the other way around. So if we have it, we're going to take it out of there. So now our current exceptions list will only have the exceptions that we no longer want. So with that, we go through that. I'm just going to make my life easy by copying that, but instead I'm going to say remove collision exception with that. So now we have make sure that in our physics process, our layers get synced and our exceptions get synced, and we no longer have to worry about that. I'm doing that regardless of whether we're frozen or not, because we might still, even if we're frozen, we might still get collisions because we are basically now static bodies. Although I think that the freeze logic in that way does not work that well. And one of the things that I believe that really should be done here is that when we look at our frozen mode, is we should actually have freeze mode on kinematic most likely. But we might actually add that in here in our ready and say freeze mode is kinematic. And we probably need to do that for the collision hand as well. But for now, I'm just doing that for my fingers. That's good enough for what I want to do. Okay, so in theory, that should mean that our fingers are now going to be, well, when I'm using the, what you call it? What did I call it here? The teleport mode, that should now work because on teleport, it's frozen and we just do what we need to do. But our real code, we're going to add in a minute. So our right hand should not work. Our left hand should work. And here, obviously, it should be copying it back to our skeleton, which means that our fingers should be working as well. So let's see how close we are to what we want to have. Come on. There we go. All right, so this is obviously, that's going really weird. Oh, that's completely screwy as well. So we can see that our globes stay where they are. Our collision shapes are working perfectly. I bet you that I've moved that the wrong way around. That is, looks cool, but that's not the way that it's supposed to be. All right, so I bet you that this is, I always get this the wrong way around. I'm pretty sure that this needs to be like that. So let's see if that fixes that problem. Okay. No, that makes it 10 times worse. All right, so we have a different problem. Oh, because we are doing global transform, and thus we're not getting the transform between the bones. Ooh, that's going to be interesting. That's going to be a problem if it doesn't do this in the right order. So that gives me enough reason to say I shouldn't be doing this here. I should be doing that. I should be doing this in the as a separate object, or maybe in the collision hand itself. I think I'm indeed going to move that into collision hand itself. So we're going to take this out, which interestingly enough also means that we're actually not going to care about the bones. We're purely going to do the physics handling here. So we no longer care about that. We no longer care about these. Okay, cool. Sweet. All right. Which means that obviously this is going to be wrong over here. So we just need to do that. And it's already set there. So I'm actually happy to not do this here because we're going to be setting it right after. So it's just going to be collision finger. That's got all the logic for copying stuff. Very cool. So now we're going to go to physics process here. Oh, we have process here. Very good. So what are we doing here? Oh yeah, that's whether we're having that visible or not. If hand skeleton our physics should run copy our physics bones to our skeleton. And actually, one of the other things that I really would like to do so all that I want to do here actually is, and so if we're enabled and our parent, no, sorry, if not enabled or our parent is frozen, then we freeze this thing as well and we just do that. Cool. Because that means, because the other thing that I'm thinking about, or that I'm wondering about, when we get to a situation where we want to pose a hand, we might want to turn off the physics logic that we have here. We might actually just want to position the fingers as they are, and we're just not going to do the collisions the other way. And again, that's where it does become important that we have our freeze mode kinematic. Okay. And who knows, maybe I'll do that differently. I'm not sure, because I think also when I do the pose hand on something, yeah, I might freeze more. We'll see. I'm not sure yet. So now here we have a skeleton. Then we need to go and loop through phone name in. I still want to go and rename that. Let's go and do that first. All right. I really should be just doing a search and replace, but I'm lazy. So this is actually not that. We're just going to call this finger joints. That makes far more sense. Finger joints, finger joints, finger joints, finger joints, finger joints, finger joints, joints. Why are you suddenly saying big loop? What are you about? I bet that the little battery on top here is getting empty. Well, while we're working, I might just put it in the charger for a little bit. Luckily, I got the charger right next to me. There we go. Finger joint, finger joint, finger joint, finger joint. There we go. Cool. Search and replace, manual style. Okay, so let's go back to process. Okay. Yep. Bar phone transforms is array transform 3D. There we go. We're going to make our life a little bit easier. So we're going to do this in 2 steps. I'm going to say, actually, that needs to be a dictionary. And that should now be is. That should be a that. Okay. Together transforms. In global transform is global transform inverse, so that we don't want to do inverse every time because that's slow. So we're just going to do that one time. Bone transforms bone name is finger joints dot bone name dot body dot global transform. Again, I'm going to assume that it's actually at the end. So I think it's at the end, but I could be wrong. I always mix this up. Okay, so we have a bone transform. Cool, sweet. So we have that now for all our finger points. Now we need to change them to local. Convert to local and apply. So we're going to again do for bone name there. For bone ID is parent skeleton dot find bone name var parent ID is hand skeleton dot get bone parents bone ID. Okay, so now we have the bone ID of the bone that we're manipulating, and we have the parent of it. So if bone ID bigger or equal than 0, so we have a valid bone ID, and we say if parent ID bigger or bigger or bigger or equal than 0, then we have a parent ID. So if we have a parent ID, Okay, I might actually do this slightly smarter. And I'm actually going to go and put that as an int. And I'm going to go and use the bone ID int there. And I'm going to go and do this. If we have a bone ID, then we add it in there. Cool. That should always be the case. If that's not the case, then we have a big problem. But now here we can actually go and say we're going to go through our bone transforms, because now we have all the bone transforms that we need to update. Yeah. Then we're going to go get our parent ID of our bone ID. Perfect. And then if we have a parent ID, cool. Then what we can do, let's actually make our life a bit easier and say bone transform is transform 3D is bone ID. Oh, we have a bone transform. If we have a parent, we're going to say bone transform is bone transform. Bone transform is bone transform times bone transform parent ID inverse. Maybe we should stack those as well. Make our life a little bit easier. I think so. Int bone transforms. I'm really being nitpicky right now. Which means that here we can say bone transforms ID. Actually, yeah. No, let's prevent a lookup. I'm really being pedantic. Bone transform. Inverse. Okay, cool. So now we can just do inverse. And that saves us an expensive inverse. Bone ID. And again, this is for as little stuff that we're doing here. This is completely overkill. But hey, why not? I'm wondering if the lookup in a dictionary isn't more costly because of the way that it works, but oh well. Okay, so last but not least, and skeleton dot set bone pose bone ID bone transform. Boom. All right, so that should now copy things correctly, I hope. Let's see if we made it good or if we screwed it up. Okay, got some wires that are crossing, but whatever. No, but that could still be that we are doing things the wrong way around somewhere. Is that then this way around? And that would make sense that we also should have this the other way around. Oh, wait a sec. Yeah, inverse times itself. Oh, yeah. Ooh, look at that. So that one's working. Now that obviously is not yet working because we're not doing our momentum thing yet. So that's the next thing to try and do. See if we can line this all up. It definitely is screwing up with the momentum of this thing, which is kind of hilarious. And that's also my worry. Because yeah, who knows? That's really where things get hairy. And you know, we did have our own moment logic, so we'll see what we can do with that. Okay. So one other thing that we are going to do over here is angular demp. Let's make that nice and high. We really don't want any angular velocity to be kept over. And then let's go back here where we already have a version of this logic. Let's grab our body states. And then we're going to do this. Okay, let's have a look. Station. Oh yeah, because I took out delta. All right. And of course, we don't have factor because I calculate that one over here. All right. That should be tiny, but hopefully enough. Well, really doesn't like it very much. Okay. So now the question is it not working at all? I'm thinking actually of making this simpler and doing this similar to what the original implementation was that Detma-J had. Do I still have that? I might still have that. It's that one. Hands. Hands. Where is it? There we go. Okay, maybe we do that here as well. I actually think that's a good idea. So we're not going to do the expensive way. We're going to go and do the simple way. Get Euler, cool. And our torque is simply angular movement. And we can do that times a factor. What was the default factor that we're using here? Okay, let's just say if we just do that times 10, just to see how much difference that makes. And better, it is now going to try and keep the hand in place. Really? That is definitely way too much, but why is it not rotating at all? Yep, yeah, you're not going to be happy with that. That's fine. I don't care. Let's just do that because it's supposed to be a really small value at that point. But I think one of the other things that I really want to do is for this root bone. Where are we building the root node? Root bone. Why don't we go and say finger joint dot body dot enable false. So this one is now going to be just adjusted. Let's see if that actually, that might not even work, but you never know. And that might actually upset a whole bunch of things. Who knows? Oh, that's really going absolutely haywire. Okay, that was a bad idea. Surprising, but a bad idea. Okay, what are we missing here? I'm going back to a pin joint again because I think it might be because we're not allowing any rotation. And now we are. So let's see if that makes a difference. Oh, it does. Okay, position-wise, it's off for some reason. I don't get why that is. It's not gravity. But that's kind of cool. Okay, I want to try something else now. The whole reason why I was doing this. No, these go through the thing. Why are they? It's saying collisions, but it's not allowing. Oh, that's maybe because I am now giving way too strong rotational forces on these. So maybe I should get this rotation to be back the way that it was. I think that might have something to do. Because see how the box collision shape is still in the hand? That means that our why would it be like that? Yeah, because I think the problem is so the position is changed of that. Again, I am running into the problem that I cannot change the location of the pin. I'm thinking that for that root bone, I am going to need to do, oops. Yeah, the problem again is because I'm positioning my joints in the default location of everything, and now everything is rotated because I'm not rotating that or not positioning that that one, it's going to be a problem. So we're going to do something here. So excuse me. So what I'm probably going to do, this really sucks, but it is what it is. Run 3D. Stuff. Just so that we can properly set it up. Pin. Okay. We might actually eventually make this a slider joints, and that's then the way that we can lengthen it. We can slide on the orientation of the previous joint. Not sure if that will work, but we'll see. For now, I want to do it like this. But that means that's now for this one. That's what is that one? Oh, no. Because we got these properties, but you can never set these properties properly. Or I never figure out how to do that. Yeah, set param x. Why does that not autocomplete? No. Dot set param x. So. Angular lower limit. Might just be pi. I always forget that. No, I think it's pi. I think it's not 2 times pi, it's pi. Y, Z, Z. No, this is minus pi, minus pi, minus pi. Why is it not happy? Oh, because that's called upper limits. Very good. Paste. Paste. Okay. Now let's say if we have let's see. I don't think I'm gonna like this because this means that my hand can move away from where my rigid body is. It is so weird. There has to be a better way of doing this. Well, let's first see if my feeling is correct here. Actually, before we continue with anything here, I want to turn this back to what it was. I think that's now back to what it was. Okay. And this is going to be param. Then your lower limits. Give it a centimeter. So this means that we can move our point within that. Okay, let's see if this returns it to what it is. Now, obviously, our this is going to screw up our positioning even more. Oh, but our rotation doesn't even work anymore. Slowly curling the fingers. So yeah, we definitely don't have the strength now to turn these things. And I wonder if that's because what the heck? Okay, so this now, the hand now falls back because we don't have any sort of strength to push the hand back to where it should be. That is kind of funny. But yeah, so that doesn't really work. All right. So do I just want to go, whoops. Okay, let's go back to what we just had. Angular momentum is angular momentum. Let's make that a bit smaller. Okay. Let's actually make that some export bar apply torque. True. Export bar. Torque. 0.1. So if we can change it easily. I'm never going to see this, but whatever. This actually needs to be false by default. Why torque is not a function? Why does it say that? That's a function of rigid body 3D. See? Oh. Oh, your rigid body. Why? I think that is going to require a restart. Ooh, I missed chat. Is it good you're tackling this? I wish hand detection was easy in any VR app. It's so hardcore. Trying to work it out with a lot of time. Well, I'm doing it on steroids right now because I'm trying to. Script. Oh, ha 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 ha! That's why I screwed up. Let's change that to enable torque and enable force. There we go. That'll probably work a bit better. So I have to figure it out if I can do something about this. E-body on base object, no. I don't think that's actually in my code, is it? Yeah, so I'm doing all funky things because I'm trying to make it with physics. But let's see if I can quickly find it. Here we go. If you go to GitHub Godot engine Godot demo projects, go away. I have my recovery code. So what are you on about? No, I don't want to do it better. You go to XR, and then you go to hand tracking demo. There is a nice demo here that shows you how hand tracking works. And you can play around with that, and it does all sorts of fun things, and it's a straightforward implementation. It doesn't do anything overly complex. But it should work on your Quest and on Steam VR, so all good. Okay, 958. Parent body. Okay, so somehow we so we just checked if this is in there. Cool. And then we say assign it, and it says I'm doing it on top object of nil. It's there. What are you all about? Crazy thing. I'm not gonna worry about that right now. That's probably just because it's a tool thing and it doesn't like it. And really, to some extent, I shouldn't be running this in tools anyway. So yeah, we are doing that with our coefficients. Thingy. Enable force. So let's go and do something similar here. This time again, I'm just going to copy it. Where are you? I lost it. I'm going to base this on the simpler version, where we just tweak things because we know what we're on about here. The other thing which I think I'm going to do in a minute is put the rigid body in the center again, because I think we have an issue with or maybe I'll turn off automatic center so that it always the center of mass is always in the center of the collision shape. Why can't I find this thing? Oh, here we go. So same thing. New movement. Minus position. So we get where do we want to go? And we go and apply a central force. Now in this case, I actually want that. Yeah. Force. Yeah, parent, right? I'm going to apply the reverse of that force to my parent. And that actually apply force, I think that needs to be. Because I don't want that central, I just want that normal. Where are you? Here, apply force. And that then needs to be at a position. And that is then going to be global position minus parent with global position. So that at least should cancel those two forces out. And the other thing that I really want to do, which is again on finger, it's part of this. Let's go have a look. Center of mass. Also, we're going to put that center of mass mode is custom. And then because we're not setting, if you put it to custom, we can actually set a center of mass. By default, that's 0, 0, 0. So Okay, so let's see if that makes a difference. Might not, but might. I have no idea. Let's see if this makes it work. I really think that we're stretching a few things. Okay, so it's too slow in going there. And my last bone is not working very well. I don't know why. It's working sometimes. And sometimes it's rotating the wrong way around, which is really funky. So the way that we are calculating our rotation, sometimes it's figuring out that rotating the, oh, it's because when I'm moving it too fast, it figures out that rotating the wrong way around is going to be the smarter way to get there. Yeah, that's fun. So as long as I, well, that's going to fix itself if we actually move everything quite quickly. But yeah, that's our old problem that, huh. Oh, we actually aren't applying our force yet. And again, I'm not quite sure if this is really how I want it to do. I really wish there was a way to just edit the offsets of because that would just make so much more sense. It's getting late, so I'm not gonna worry about this just yet. I'm gonna focus on this at least working somewhat good. So let's go to 0.5 and see how much better that is. Because when we did 1, that worked really well, but then I think we were too strong for. So yeah, now we can see that's working pretty quickly. It's slightly too slow. And yeah, sometimes it still goes the wrong way. And again, we can change everything to 6 dove. And obviously, we should really change our collision shapes to be the right size. It's kind of trying to get there. I don't get why my sideways rotation is the way that it is. Why is it? Why are my fingers going all the way scrunchy? That makes very little sense. Is that again because my positioning is off? Or why is that? Because compared to that, yeah, it's definitely not coming up with the rotation that it should be getting. But I don't know if that's because we're applying the wrong forces. Although we can see that all the collision shapes are in line, so we can see that some of them are not what they're supposed to be. So yeah, I think it is because we're not taking the position in there. That is weird. So maybe we do need to do something with the positioning. The other thing that I want to try, we go here. Now we still, oh, I didn't want to knock you off the table. We still don't have that when we press that. This should be causing the fingers to bend back. Where's my drawer? Table. It shouldn't press the hand through. That does not make any sense. That should be bending the fingers back. But it's not. And that was the whole reason for doing this. This should be pushing back on that finger. The finger is light. It's hitting a static body. Why is it not moving? All right. Let's go really crazy. Oh. All right, now I'm going to go silly with this. Now I'm going to go silly with this. Might as well try it. Oh, how's the chat going? Oh, yeah. I've got too many functions here. Okay. What I actually want to do is I'm going to always use a 6 stop. And I might now change the limits depending on which bone we're setting. But we're gonna let it shift a bit. We don't want it to shift, but we're gonna let it do that if if the need arises. Yeah. And we might need to do something with the parent bone here. Okay. Okay. We're gonna go need that. That should be set to that in this case. So let's go and do that here. That's the one that we sent through there. Cool. Finger joins body dot parent body is parent. All right, and set that as well. Cool. So we have parent body being sent through. In this case, we're gonna why is that not? I defined that up here. Oh, let's call a parent body. Let's be consistent. Okay. So if we have a parent body, we do that. Now, obviously, I'm now going to make that true as well. Again, we just need to cancel those forces out so that the hand doesn't start moving. All that we're doing is we're trying to move the bones in place. excuse me. Full centimeter movement, full 360-degree movement. Don't want you guys anymore. I don't care about those. We now know that does do something. All right, see what that does. And again, I don't like the initial movement, but it's just what it is. Okay, it is funny, but yeah, I got a water hand now. I got a wobbly hand. Yay. So that's what I was afraid of, that if we allow the bodies to move. Oh, let's put a linear damp in there, so that we have as little lateral movement as possible. Oh, I'm in the wrong file. That's right. Let's see if that does anything useful. Well, it stops the movement from going completely crazy, but it doesn't do what it is that we want to do. Now, what I find really interesting is we have rotation. Yeah, that just doesn't make any sense. It's funny as can be, though. But still, even with that, yeah, no, you're really messing up now. Oh. No. It's still pushing the fingers through, and that just doesn't make any sense, because that is something. And again, because these stupid triangles, I can't actually see whether it is really the fingers doing something dumb, or well, it's doing something sort of. But no, it's not. It's totally not doing what it's supposed to do. But yeah, doing the movement thing is definitely not the right thing. But it is pretty clear that some of these bones, we do have an origin moving. So okay, I've got another idea that we can do with that. I've got another idea. I'm not going to do this. No, I don't. Because it's obviously obvious that the linear thing that I'm doing here isn't anywhere near what we should be doing. Plus that the left hand is doing what it's supposed to do. Yeah, with the left hand I am changing. You know, when it's frozen, I'm assigning the whole global transform. So it is then also changing the origin. I'm going to keep this in there, but I'm going to make you false. Also, I'm going to bring that to 1. Sorry guys, I'm also getting very tired. So it is almost 1:30 a.m. here. I don't think I need to wake up too early tomorrow. Oh, that's right. I need to go. All right, so basically this should now work like a pin joint. Let's see if that does anything sensible. Expecting it to be similar to what it was before. Oh, what? What? That makes no sense. Oh, I did the wrong ones. I am really getting tired. So now it should act like a pin joint. Okay. So yeah, now we're back to that, but it being offset because that's, and it's, you know, it rotates the things, but I think it really is the positioning. Yeah, I really wish that we could just move the joints. I'm actually thinking about going slightly back to where we were in the beginning and only creating the finger joints. But when we detect that the root one is in the wrong position, is updating that. So now I'm deleting my helpers. Damn, I'm having too much fun. I don't want to stop. I want to solve this. Okay. Back to where we create this thing. Create finger. Boom. Okay. Very cool. Okay. So just what I wanna do for testing, I wanna bring this back. And this is going to be because I think if I reassign this, it's a trigger point to rebuild that. So okay. Let me think. Let me think. Bar sphere mesh new sphere dot radius 0, 0, 5, 0, 5 sphere height 0, 0, 1 distance mesh is mesh dot new dot mesh is sphere joints add distance so now we should once again see a sphere for our joints. All right, so we are not going to create you. I'm glad you're gonna try some more Godot VR, Douglas. Okay. So let's come into that. I don't really care about you. Oh, of course I went and removed all that. Why wouldn't I? Okay, so that's going to be proximal or intermediates or okay, I just want to check the sum. Yeah. That one doesn't have an intermediate. It has a proximal. Okay, cool. If we have these, we're going to create these. Cool. Okay. Might need to create some helpers then if we do it like this. If we have a for thing joins, then we do that. Else bar else bone is that's global transform that we got, isn't it? Dot get bone pose e and then and skeleton set bone pose. All right. So in this case, what we're going to do, actually going to put it here. All right. Then dots. Don't know if that's going to be smart, but you might just want to check just the origin. Now, if I remember correctly, we're not doing top ready here. We're just doing a normal bone transform. Also doing transform here. And then we're doing top level, which turns it into global. Okay. Okay. So that should only happen once or twice. Well, a little more because we've got 5 fingers, so 5 per hand, 10 times maybe. I'm just going to reposition this. This doesn't do anything right now. It doesn't change any logic. But that just helps us. Oh. Okay, let's see. Okay. Where is my other controller? I can't see. That's the only downside of this. I cannot see my desk. Oh, here it is. Okay, come on. There we go. All right. And we have a typo. Yay. Oh yeah, that makes sense because that, of course, is now going to change. All right. So here, if we have a parent ID, and what we get here is if in bone transforms has parent ID, and we use it, else bone transform is hand skeleton dot get global pose parent ID dot inverse and bone transform. Then we just use the actual parent from the bone structure. Let's see if that works. Okay. Well, that was to be expected, but we can see that our joins are now where they should be. And the thing is, they still move a little bit, which is annoying. Okay, so, all right. Okay, so we definitely need to make that a bit smarter. Okay. So what I actually want to do, instead of comparing these, what we're going to do, can I just get the position? If it's more than 5 millimeters out of place, then we're going to do this. Okay, we're gonna go and then move that into place. Then we're going to go and body transform. And that needs to be global transform. That needs to be done in global space. Cool. And now, in theory, if I do if I reassign that, that should re-update that. So hopefully this won't happen every frame. And I'm a little bit worried that it might for some of the fingers that move a little bit. Okay, we are once again hitting a error. Oh, yeah, that's the wrong one. Is it? No, how to get that? Node B. No, that didn't do anything. Okay. Maybe I have to force it. I'll still get a lot of tests, so it's... Empty it out. That's probably going to give me some errors and warnings, but I don't really care. Okay. That's kind of working. Definitely is better positioned now. So, and obviously I'm hoping that that doesn't move too much. I think with the thumb, because the thumb does move more like that. I think for the thumb, I am going to have to do... Well, that's screwed up somehow. I'm not quite sure what happened there. Wasn't happy. Yeah, I need to do something more about the thumb. Because it's the only one that really... But again, I don't even know if the metacarpal is going to be moving properly. Well, I'm not quite sure what happens there, but oh, look at that. It's definitely struggling. So I'm probably doing something that it's not happy about. Yeah, there's a lot of stuff to improve here. Yeah, I think for the thumb, we do need to get the metacarpal involved and hope that that does properly rotate. And I think that's the whole point here is because we're having movement involved. And I think that that is, that is where things get haywire. And that's kind of, you know, for those who are on Discord, I think that is also the problem that Julian has been struggling with when it comes to his auto hands. And why he's not trusting the rotations, because the tracking data adds movement in instead of making sure that everything is just rotations. And I think when we look at the physical bone setup here, and especially when we are looking at that one there, we can see that it's actually creating a bone from the center to there as a rotation, and then it's not actually using the position. It's always getting that rotation there. And then probably with that an offset to what it should be. So that's definitely something that that I could mimic, because that's, I think, where we're going wrong here. You know, when you look at this hand, basically here there should be 5 rotations, and we don't have them. So I might add the metacarpal in there as well, and just have those not doing anything. Let's see if that makes a difference. And that's really the last thing that I think we should be doing. So instead of using the proximal, we're going to use the metacarpal. So we're going to do this with the metacarpal, because I don't think that one will ever change. Because that's a fixed distance between the origin and the rest. Okay, let's see how well that works. Okay, that screwed it up initially. So what did I do wrong? What did I do wrong? So metacarpal, I did write that right. We have that on thumb, on index. So we're saying if we have any of these four, and at this point, actually, I could say anything that's not the origin. So what if I just do this? Oops. And finger has bone name. And we do that. And I'm even thinking, oh, maybe it's the there. We could even say if parent bone. Yeah. So we're going from our first one up. So basically, I think the problem is because all these bones all have the same parent bone. That's where our system fails, because we don't have 5 rotations. We just have the initial rotation here. But if we skip just that one and we create everything from that bone down, then we should be fine, I hope. However, people screwing up. Now we're even creating the tip bones. I think that's fine. That's fine. Let's see if it does something sensible. Oh, that's perfect. Oh, that's good. And the thumb is doing what it's supposed to do well. Obviously, I want to remove the tip, because the tip doesn't make any sense. And we can see that, yeah, we still have bloody metacarpal of the thumb moving. Just annoying. Oh, even all the others move. See that? That is so dumb. Well, they're internal bones, so I don't really care that much. I'm assuming that the overhead of changing those isn't too bad, and everything else works the way that it's supposed to. However, do we now have, no, we still have, if we touch something, that should bend the fingers back. Obviously, this one doesn't do it because, oh. Okay. We definitely broke that, so that's fine. We'll deal with that another time. All right, I'm gonna make sure that the tips don't get done. Yeah, that is just why are you doing that? Why would you do movement of internal bones? That makes no sense whatsoever. That makes 0 sense. And maybe we could create a helper bone there for that sort of rotation, assuming that that's not changing the distance to the, I think it is. It is just repositioning it. Okay, I want to see how much does that change when I get a real hand. You're going to notice that I left my controller away. Like, there we go. Come on, figure out that I put my controller down. You were working a minute ago. Uh-oh. No, you don't want to do that. Oh, there we go. All right, so when I'm moving my fingers, you can see that now it's not, well, no, it's still doing some movements in the inside of the hand. It is what it is, I guess. But that is kind of cool. All right. This one over here does as well. Okay, so let's go and take the tips. Here we can see that we get a bit of a squished hand because my my fingers for tracking aren't completely where it should be. Although it's not too bad because it's not repositioning the which column? These things. Oh no, because I'm only doing that for the metacarpal. That's right. Touch these guys. That's kind of cool. But yeah, I am not sure why if I put my hand on a surface that it's not pushing him back. That's what it should be doing right now, because these are just rigid bodies that are independently moving on a constraint. I don't get it. I really don't. Unless because of the way that we do the rotation, we have such a powerful rotation. I don't know. Weird. I really don't know. Okay, let's just fix the tip thing. So that's just going to be else if bone name contains tip. I think it's tip. And then obviously not. And the other thing that I really want to do before I forget, that's in process. Let's undo this one. Okay, let's see what that looks like. And again, I have no idea why this is not working. Because that's the whole reason I did this. All this work is so that if the fingers collide with the surface, it should be bending the fingers back, and it's not doing that. I don't know why. That makes no sense. You can see that it's making collisions, but I'll do a little bit, but not enough. Could it be that the margins aren't good on these things? Maybe that's why. Yeah, that's the downside, of course. These are very, very small collision shapes. All right. That's, I think, the last thing that I'll check. I'm also going to get rid of that test thing. I'm kind of hoping that that's not the reason why. It's possible that it is. Test. I'm going to make this a little bit more so that it doesn't change them that often. Yeah. Because I wonder if when I do that, whether that is going to upset the logic. I don't know. let's actually do this. Do under that. Come on, why did you do that? Okay. And now after this is all done, I'm going to go and place that back. It's kind of the same trick that I'm doing with the hand simulation. So this should, in theory, pull back this thing to where we were. So hopefully physics will properly move that bone into place that way. I don't know, that we might have just screwed that up. Let's have a look. Let's see if that makes a difference. It still works. Oh yeah, and then we were going to check the so yeah, it still seems to be doing what it's supposed to be doing. It's definitely moving the bone back into place. Yeah, I'm happy enough for that. Okay. Okay. Oh yeah, sorry, I forgot. Totally forgot what I was doing. And there we go. So nope, and shape. Right. Okay, so we got our margin is okay, boom. Our margin is bigger than our radius, so basically our fingers have no size. Yay! Which is one of the biggest problems with physics that we have in VR is we're working on such a small scale. For some reason, most physics engines don't really like that. Okay, so does that make a difference? Come on. Oh, it just gladly sinks it through it. I do not understand. Why? Why are you not doing what you're supposed to do? That is supposed to give me a force back on the things. Come on. Anyway, interesting. Very, very interesting. One thing that I'm wondering about if this is because I'm offsetting the well, that's one thing that that's one last thing that I want to try is I did this. Let's take that out because I don't think that is at all important anymore. And the other thing which is possible is that maybe it's because of the damp. Nope, that makes no difference. Okay, could it be because of the damp? We don't need linear damp anymore because we're not doing anything with linear at the moment. So let's just put that back to 0. Let's just put this to 0.5. That's gonna be funky. Because now we're no longer dampening that. Ooh. And like I said, we're no longer dampening things. Really? Okay, well. It's definitely not making a difference. Excuse me. All right, guys. I'm not going to solve this tonight, and I really need to get some sleep. So, interesting experiment. I honestly don't get why this is not working. With maybe the only exception that the torque that we're applying here is so strong that it overrules the pushing back. But at the same time, I don't think that makes sense. So I don't know. It's in my opinion, we should see at least something happening. So yeah, it's a bit of a mystery to me. Now, the other thing, of course, is that we're making our fingers really light. But when we have really light fingers and we're touching them up to a static body, that should exert enough force to go back. So again, I don't really get that. Why would that be failing? Yeah. Now, I do definitely think that I should be doing more work on the collision shapes. Because I'm not happy about the collision shapes at the moment. There's definitely a lot of work still to be done when we grab things, because we really need to disable most of this logic when we grab stuff. So that's something that's going to be interesting to still add in. So yeah. Yeah, the only other thing that I can think of is that we should have our rigid body. And again, that should work because it's got the adjustment for what's it called, for center of mass. So that should just work. It makes no sense. So yeah, I really wonder if we're applying too much torque or something like that. We tried lower torque coefficients and saw that the fingers were moving much slower, and we still couldn't push back. And again, it should exert much more force when we push against something. So I don't know. Obviously, right now we will be able to completely bend our fingers back, because we don't have any constraints on our fingers. That would be something that I need to look in more. See, okay, how can we restrict that? All right, I'm going to leave it there, guys. Thank you all for watching. I hope this was interesting and informative. I do think we got quite a few things figured out and quite a lot of ingredients there. It is just a matter of, figuring out the last little bits and seeing if we can make it work better. But in broad strokes, I'm pretty happy with how this works. So yeah. Again, thank you all for watching, and I'm gonna leave it there. So good night, everybody.